In order for the components in an assembly to be positioned correctly and have the desired mechanical motion, joints are applied to control their movement in the assembly. Joints can only be added to components, which represent real-life parts that would be assembled together after they're manufactured. Bodies can't have joints added to them, but components can be created from those bodies and then have joints applied. Each component has a total of 6 degrees of freedom, meaning it can move in 6 different ways. It can move translationally along the X, Y, or Z axes, or it can rotate around each of these axes, totaling to 6 different degrees of freedom. Joints are used to limit these degrees of freedom, leaving certain ones open to mimic mechanical behavior. In order for joints to be applied, reference geometry must be selected on both components to relate them together. If you've used other CAD software before, you may be used to selecting faces and edges to relate parts to one another. In Fusion 360, all that you need to select is a single point on each component to relate them together. These 2 points will then snap together, with the first component moving to the location of the other. Whenever a joint location is selected on a component, this glyph will appear at that spot. It is a white circular disc with one of the halves cut out. This shape indicates a few details about how the components will snap together. Let's take a closer look at this glyph. The first aspect is that it's two-dimensional, or planar. In Fusion 360, joint origins always snap together so that these planar faces are overlapping, making the orientation of this glyph extremely important for orienting the components correctly. Even if the joint origin is specified at the right location on the component, having the face oriented incorrectly will still keep the 2 components from lining up correctly. The second aspect is the orientation of the cutout. This corresponds to a coordinate system, where the X and Y axes lie within the same plane as the glyph, and the Z axis points outward, normal to the plane. Additionally, the X axis runs along the flat edge of the cutout at the center, and the Y-axis points upward in the direction of the circular edge. This orientation is consistent for all joint origins. Now that you're familiar with the orientation of the joint origin, let's select 2 joint locations on these components and see how they snap to one another. I'll enable the joint command, and I want this component on the left to match up with the one on the right. I'll hover over the front face, and I can select any of the joint locations automatically generated in Fusion 360. Notice that the joint glyph's plane aligns with the front face of the component, and the semicircle faces upward. Comparing this to the same point on the other component, I know that these 2 outer faces of the components will line up, since the joint origin's planes coincide with the front faces. Additionally, the cutouts are both pointing upward, meaning that these 2 components will snap together in their current orientations. I'll select the joint location on the left, and then the one on the right. And the 2 components snap together at the specified points. In this case, the components snap together opposite the desired orientation, and I can switch the orientation simply by clicking the flip button in the dialog box. Now these 2 components line up as desired. All that needs to be specified is the joint type, which will open up degrees of freedom for the components to move. In this case, I'll select the slider type, which allows for translation along a single axis. Now, the 2 components move as expected, and we're aligned to one another by selecting individual points on each component.